everyone, welcome back to our channel Electron Chemistry Tutorial. Now let us discuss remaining colligative properties. So now before video we have done objective bits on RLVP and elevation boiling point. Now let's do some objective bits on depression in freezing point and osmotic pressure. Okay. So before going to that, some important formulas. Okay. Depression in freezing point. Okay. So first of all, what is freezing point? How to define? So freezing point is a temperature at which solid and a liquid form of liquid equilibrium with each other. Okay. Suppose for example, at 0 degree Celsius, ice equilibrium with its water. Okay. So at 0 degrees the temperature is called simply freezing point of that water. Okay. Now pure solvent to solution, freezing point decreases because in solution some of the solute particles occupy the surface area. Okay. So that's why evaporation decreases, so vapor pressure decreases. So simply vapor pressure is directly proportional to what? Freezing point. Freezing point. Okay. So at that freezing point, solid liquid equilibrium with each other, nothing but vapor pressure of the solid and liquid same. Okay. So what I am trying to say here? So from pure solvent to solution, vapor pressure decreases, freezing point also decreases. So this decrease in freezing point is also known as depression in freezing point. So that is denoted as delta TF. Okay. Now delta TF is simply delta TF is equals to TF not pure solvent freezing point, TF as solution freezing point. Okay. So suppose for example here water freezing point is 0 degree Celsius, but salt water freezing point is a minus 1.8 degree Celsius. Okay. So by adding salt in water, in pure water, we will get salt solution, that is solution. So in that solution from pure water to solution, freezing point decreases. Clear? So that's why, so this is for suppose here this is for water, this is for salt solution. Okay. Depression in freezing point also proportional to molality of that solution. So that formula is simply delta TF is equals to KF into M. KF is a constant of depression in freezing point constant or cryoscopic constant. Okay. Now finally delta TF is equals to KF into molarity formula, weight by gram molecular weight of solute into 1000 by weight in grams. Clear? Now osmotic pressure. Okay. So before going to that, what is osmosis? Osmosis means inflow of solvent molecules from dilute solution to concentrated solution through semi-permeable membrane. So this process is called osmosis. Okay. Suppose this is a dilute solution. So this is concentrated solution. This process will take place until both concentrations will be equal. Okay. Now the pressure applied on the solution with more concentration to stop the inflow of solvent molecules from dilute solution to concentrated solution, the pressure is called simply osmotic pressure. Osmotic pressure, that is pi. Okay. So the pi is equals to CRT or pi is equals to CEST. So instead of R we can write S, solution constant. Okay. So but the solution constant also same value as that of gas constant value. So simply you can take pi is equals to CRT. C means concentration of solution, constant of the solution, temperature of that solution in Kelvin, absolute temperature. Okay. So then simply pi is equals to concentration nothing but number of moles per volume into RT. Number of moles nothing but weight by gram molecular weight of solute into V here RT. Okay. These are possible formulas. Okay. Now I want to tell you one more thing. If solution A solution B, both are have same osmotic pressure, the solutions are called simply isotonic solutions. Isotonic solutions. Suppose for example, blood isotonic saline water. Blood isotonic with saline water. If the pressure is more than osmotic pressure, then osmosis will reverse, means that is reverse osmosis. That reverse osmosis is used in the desalination of seawater to prepare a crystal salt from seawater. Clear? Now, Van't Hoff factor. Van't Hoff factor. See, in that solutions, solute may be dissociate or associate. Okay, maybe the solute will be dissociated. The solutions get more colligative properties. Maybe associate, they will get less colligative properties. Okay, so that's why Van't Hoff was introduced I factor to determine the extent of dissociation or association of that solute in solution. Okay, so during that dissociation association will get abnormal molar masses of that solute in that solution. Okay, so that's why I factor is introduced for the determine extent of dissociation or association of solute in that solutions. So then I factor can be calculated by I factor is equals to normal molar mass by abnormal molar mass. Abnormal molar mass means the molar mass may be lower or higher than the expected value. Okay, so I factor also calculated by total number of particles after dissociation or association by total number of particles before dissociation association. Okay, so by deriving equation we will get for dissociation I factor I is equals to 1 plus n minus 1 into alpha. Here alpha is equals to degree of dissociation. Degree of dissociation. Okay, now alpha is equals, by this formula alpha is equals to I minus 1 by n minus 1. Okay, suppose we want to calculate I factor, we can use this formula. We want to calculate degree of dissociation, we can use alpha is equals to I minus 1 by n minus 1. Okay, for association I factor is equals to I is equals to 1 minus 1 minus 1 minus 1 by n into alpha, or alpha is equals to 1 minus I into n by n minus 1. Okay, so you have to remember these formulas for calculating alpha or I factor. Okay, clear? After introducing I factor, colligative properties, the formulas of colligative properties can be modified as, so RLVP is equals to actually XS but into I factor, and elevation in boiling point is equals to what, Kb into molality into I factor. Now delta Tf, depression in freezing point, I into Kf into m. Now osmotic pressure pi is equals actually CRT. After introducing I factor, it modified as I into CRT. Okay, clear? Now let's do some objective bits on these formulas. Okay, let's start. First problem. AB2 is 10% dissociate in water to A plus 2 and B minus. The boiling point of 10 molar aqueous solution of AB2 is. Now we have to calculate boiling point of solution TBS. Okay, so for that the delta TB is equals to TBS minus TB naught, but we don't know delta TB. For that delta TB is equals to, AB2 is a dissociate, means 10% dissociate, means we can use a modified formula after introducing I factor. Clear? So simply I factor into Kb into m. Okay, so for calculating delta TB, Kb is given as 0.5, molality is given as 10.0. So but we have to calculate I factor is equals to dissociation. For dissociation I factor formula 1 plus n minus 1 into alpha. Okay, now I factor is equals to 1 plus n means number of ions after dissociation. Ab2 dissociates into A plus 2 plus 2B minus 1 cation but 2 anions. So how many ions? 3. So n is equals to 3 here. 3 minus 1. How much percentage is dissociated? 10%. Means alpha is taken as 10%, means 10 by 100. Okay. Now 0 0 cancel. 1 plus 2 into 0.1. 1 plus 0.2 means how much? 1.2. I factor is calculated as 1.2. Now, after calculating I factor, we can calculate delta TB is equals to 1.2 into I factor calculated. Kb is given as 0.5. M molality is given as 10.0 means only 10. How much? 6. Delta TB is calculated as 6. Now we have to calculate TBS. TBS is equals to delta TB plus TB naught. Delta TB calculated as 6. TB naught, boiling point of water given as 100 degrees Celsius. Now simply 106 degrees Celsius. Okay. If dissociation or association is given, so we can use the modified formulas of colligative properties. Clear? Next second problem. This is previous bit AP Engineering 2016. 6 grams of non-volatile non-electrolyte X dissolved in 100 grams of water freezes at minus 0.93 degrees Celsius. The molar mass of X in a gram per mole. So, what is the formula? Simply freezing point relation formula. Delta TF is equals to KF into molality, means weight by gram molecular weight of solute, that is X into 1000 by weight of solvent, means water in grams. Okay. Now we have to calculate gram molecular weight or molar mass of X, but we don't have delta TF also. For that, delta TF is equals to T naught F, freezing point of water, minus freezing point of solution. So freezing point of water always 0 degrees Celsius, minus TF S is given as minus 0.93 degrees Celsius. How much? 0.93 degrees Celsius. Minus of minus will get a plus, no? So 0 plus something means that's something only. Okay. Now, so this value substituted here, we can calculate gram molecular weight. Now, delta TF is calculated as 0.93 degrees Celsius. KF is given as 1.86 for water into weight of that X 6 grams. 6 grams by gram molecular weight or molar mass of that X into 1000 by 6 grams dissolved in 100 grams of water. Okay. In this formula, we can substitute their values. Okay. So now, gram molecular weight is equals to 1.86 into 6 10 60 by 0.93. This will goes to here, this will comes to here. Okay. Now, how much? Almost 1 times, 2 times. 60 into 2, 120 gram per mole. Okay, gram molecular weight of that X is 120 gram per mole. Clear? Next, third problem. This is also previous with JEE 2019. The freezing point of a 4% aqueous solution of X is equals to freezing point of 12% of aqueous solution of Y. If the molecular weight of X is A, then molecular weight of Y is. Okay, simply what is said? Freezing point of X is equals to freezing point of Y. X with 4%, Y with 12%. Okay. Now, what is the formula of freezing point? Kf into molality. What is the molality formula? Weight by gram molecular weight into 1000 by weight of solvent in grams. Okay. Now, same. Kf into weight of solute by gram molecular weight of solute into 1000 by weight of solvent in grams again. So, Kf's are not given, simply ignore them. Now, 4% of X solution means 4 grams of solute, means X is dissolved in 100 grams of solution. Then what is the weight of solvent here? Solvent weight means water weight is equals to 100 minus 4, 96. Okay. So, simply here weight is given as 4% means 4 grams by gram molecular weight of XA into gram molecular weight of X is A into 1000 by weight of water, how much? 96. Now, 12% means 12 grams of what? Y in 100 grams of solution. Means solvent weight is equals to 100 minus 12. How much? 88. Now, 12 grams of solute by gram molecular weight we have to calculate 1000 by 88. Okay. Now, here 1000 mutually cancelled. Okay. Now, gram molecular weight of Y is equals to 12 into A into 96 by 4 into 88. Okay. So, by simplifying this we will get 3.277. So, A also there, A. So, gram molecular weight of Y is equals to 3.277 A, simply approximately 3A. Okay, clear? Next problem. Now, fourth problem. This is also previous JEE Mains 2019. The freezing point of benzene decreases by 0.45 degrees Celsius when 0.2 gram of acetic acid is added to 20 grams of benzene. If acetic acid associate to form dimer in that benzene, the percentage association of acetic acid will be. Okay, we have to calculate percentage of association of acetic acid, alpha %. For that, therefore, alpha is equals to, for association, degree of association, alpha is equals to 1 minus I into N by N minus 1. Okay. Now, which will get associate acetic acid. What is the formula of acetic acid? CH3COOH. Associate to give dimer. Means in benzene due to hydrogen bonds it will get dimerization. OH taken twice. Okay, means N is equals to 2. Okay, now, but I is not given. For calculating I factor, we can use freezing point formula. Delta TF is equals to I into KF into M molality. But molality is not given directly. I into KF into molality formula, weight of solute by gram molecular weight of that solute into 1000 by weight of solvent in grams. What is solute here? Acetic acid. So simply 0.2 grams of acetic acid is added to 20 grams of benzene. So benzene is a solvent here. So benzene is what? Solvent. Okay, now see here, delta TF is given as freezing point of benzene decreases by, so means the depression in freezing point 0.45 degrees Celsius. Okay, delta TF value 0.45 degrees Celsius. I factor we have to calculate. KF is given as for benzene 5.12, weight of acetic acid 0.2, molecular weight of acetic acid how much? 60. How to get? 2 carbons 12, 24, 2 oxygen 16, 32, 4 hydrogens, each hydrogen 1, 4. How much? 60. Okay, now 60 into 1000 by how many grams of benzene? 20 grams of benzene. Now this 0, this 0, this 0, this 0, which will cancel. 2 ones are 0.1. Okay, now I factor I is equals to 0.45 into 6 by 5.12 into 0.1 here 10, 1. Okay, by simplifying this we will get 0.527. Now alpha is equals to 1 minus I factor is calculated as 0.527. N means dimer means 2 by N minus 1 means 2 minus 1 is equals to 1 only. By simplifying this we will get 0.946. But percentage of alpha means 0.946 into 100 means 94.6%. Clear? Degree of association alpha percentage is equals to 94.6. Clear? Next. Now next problem. So it is similar to the before problem, fourth problem. So you have to do it. I will give you int. Okay. Now molecules of benzoic acid dimerizes in the benzene. Same. W grams of the acid means benzoic acid is dissolved in 30 grams of benzene. Shows depression in a freezing point is equals to 2K. Means delta TF is given as 2K, 2 kelvins. If the percentage of association of the acid, benzoic acid to form dimer in the solution is 80%. Means alpha is given as 80% means 80 by 100. So much 0.8. Okay, now. So the weight is what? So here KF also given 5. Then gram molecular weight of benzoic acid is given as 122 gram per mole. 122. Weight of solvent W also given. W in grams, that is what? 30 grams of benzene. Okay. So what is the formula? Simply first we have to calculate I factor for association. Association I factor is equals to 1 minus 1 minus 1 by n into alpha. Okay. See here n is equals to dimerization means 2. Alpha is equals to what? 0.8. So by substituting these values we will get I value. Okay. So then delta TF is equals to I into KF into W by gram molecular weight of that solute benzoic acid into 1000 by what? Weight of solvent in grams. We have to calculate weight. So remaining all values are here. So you have to calculate what more? Weight. You have to do it and write down the answer on the chart box. Clear? Next. Sixth one. This is also previous JEE 2019. So molar depression constant for a solvent 4.0 Kelvin kg for mole inverse. Kf is given as 4.0. The depression in the freezing point of the solvent for 0.03 moles per kg of solution. Means molality is given 0.03 moles per kg of K2SO4 potassium sulfate. Assume complete dissociation of that electrolyte. Complete dissociation means 100% dissociation. 100% dissociation means I factor is equals to n only. How to get here? I factor for dissociation I is equals to 1 plus n minus 1 into alpha, right? Now 1 plus here dissociation of K2SO4 means K2SO4 dissociate into 2 K plus ions and 1 SO4 minus 2 ions. So 2 cations, 1 anion means how many ions? 3. 3 minus 1 alpha, complete dissociation means 100% dissociation, 100 by 100. Okay. 1 plus 3 minus 1 means 2. How much? 3. So n equals to 3. I also 3, no? Clear? Now we have to calculate depression in freezing point. Delta TF is equals to I into KF into M. Okay. I calculated as 3. KF is KF molar depression constant. KF is given as 4 into molality is given as 0.03. So how much? 12 3 is 36 but 0.36 kelvins. Okay. Next. 7th one. This is also previous JEE 2021. 2 molar solution of a weak acid HA has a freezing point minus 3.885 degrees Celsius. The degree of dissociation of this acid means alpha we have to calculate, that is equals to for dissociation I minus 1 by n minus 1. Okay. But I is not there and n is equals to H plus A minus means 2. 1 cation, 1 anion. For calculating I, we have to use the depression freezing point formula. Delta TF is equals to I into KF into M. Molality is given 2. So means here delta TF also not there, that is equals to TF 0, freezing point of water minus freezing point of solution, 0 minus minus of 3.885 degrees Celsius, simply 3.885 degrees Celsius. Now here I factor is equals to delta TF by Kf into m. Delta Tf is calculated as 3.885 by Kf is given as 1.85, m is given as 2. By multiplying these two, we'll get almost 3.70. 1.05. I factor is calculated as 1.05. Degree of dissociation alpha is equals to I minus 1. I value 1.05 minus 1 by n value 2 minus 1. 2 minus 1, 1 here, 0.05. Okay. Alpha is calculated as 0.05. Degree of dissociation of this acid dash 10 power minus 3. Means to get 10 power minus 3, this value is adjusted as 5 into 10 power minus 2, simply 50 into 10 power minus 3. So simply what is the value here? 50 into 10 power minus 3. Clear? Next problem. Next 8th one. This is also previous JEE 2019. It's very simple problem. You have to do it. I will give you hint. Okay. This is for homework. Okay. So potassium tetrahydromercurate is 40% ionized in aqueous solution. The value of its Van't Hoff factor. So for ionization or dissociation, what is the formula of I factor? I is equals to 1 plus n minus 1 into alpha, no? Okay. 40% dissociation means alpha is equals to 40 by 100, that is equals to 0.4. Okay. So now here for n, K2, this is a complex compound, dissociate to give 2 cations, 1 anion. So simply n is equals to 3. Here n equals to 3, alpha equals 0.4. You have to calculate I. Okay, and write down the answer on the chat box. Okay, next 9th one. This is also previous 2019 JEE. The solution is prepared by dissolving of 6 gram of urea, its molar mass 60, and 1.8 gram of glucose, its molar mass 180, in 100 ml of water at 27 degrees Celsius. The osmotic pressure is, so what is the formula of osmotic pressure? Pi is equals to C into RT. Okay. Concentration not given directly, but 2 solutes are given. For that, total concentration is equals to C1, means concentration of urea solution, concentration of glucose solution. Okay. Now, concentration nothing but a number of moles per liter or V in ml into 1000. Plus this is for urea, N1 V1. So then N2 V2 into 1000. Number of moles nothing but number of moles also not given. Weight by gram molecular weight is given. Simply instead of N1, urea weight 0.6 by molecular weight 60. Volume 100 ml into 1000 plus here number of moles of glucose means 1.8 weight, gram molecular weight 180 by same again 100 ml into 1000. Okay. These two zeros and this is 0, this 0 cancel, these 3 zeros cancel. Okay. Now 0.6 by 6 means 0.1, 1.8 by 18 means same 0.1. How much? 0.2. Total concentration calculated as 0.2. Now y is equals to CRT, concentration 0.2, solution constant or gas constant in liter atmosphere 0.0821. Okay. So that is constant value, we have to remember that. So next T, temperature is given as 27 degrees Celsius plus 273, how much? 300. Okay. Now 2 into 0.821 into 3. 3 2s are 6 into 0.821. How much? 4.926 atmospheres. Okay. Next problem. This is also previous JEE 2019. The osmotic pressure of a dilute solution of an ionic compound XY in water 4 times that of a solution of 0.01 m barium chloride in water. Assume complete dissociation of given ionic compound in water. The concentration of XY in moles per liter. Simply pi is equals to CRT. So this osmotic pressure for maybe ionic compound XY. So this is for maybe concentration C1. Okay. So then now osmotic pressure for barium chloride solution, concentration C2 RT. Simply this RT values are ignored when compare both osmotic pressures and concentrations. Therefore pi XY by pi BaCl2 is equals to C1 by C2. Okay. Osmotic pressure of XY how many times? 4 times than the barium chloride solution. Osmotic pressure of XY compound 4 times than the osmotic pressure of barium chloride solution. Osmotic pressure of barium chloride solution. Then we have to calculate concentration of XY solution, but barium chloride solution is given 0.01. So here C1. So what is the C1? 0.01 into 4 means 0.04 or 4 into 10 power minus 2 moles per liter. Now 11th one, this is also previous AP Medicine 2016. A 5% by mass of an aqueous solution of A solution, molar mass 342 gram per mole inverse, isotonic with 0.878 percentage by mass of an aqueous solution of another substance B. Okay. So the molar mass of B in gram per mole. Okay. The solution with A compound and solution with B compound both are have same osmotic pressure. Pressure means isotonic solution. So pi is equals to what? CRT. Here also CRT. So RT ignore simply. So now compare concentrations for both solutions. So this is for A, CA, CB. Concentration means number of moles of A and volume of A in milliliters into 1000. That is equals to number of moles of B, volume means volume of solution in milliliters into 1000. So here number of moles is not given, but 5% by mass of an aqueous solution of A means 5% of A solution, that is equals to 5 grams of A in 100 by mass means 100 grams of solution. This is also same. 0.878% means B means 0.878 grams in 100 grams, that is equals to 100 ml of solution. Okay. So simply here weight by gram molecular weight, A compound weight 5 grams by gram molecular weight is given as 342 by volume of solution 100 ml into 1000 is equals to, here also same, weight 0.878 molecular weight we have to calculate by 100 into 1000. See here 100 1000 mutually cancelled. Now next continue. 5 by 342 is equals to 0.878 by m. Okay. Therefore, m is equals to 0.878 into 342 by 5. By simplifying this, we will get 60 gram per mole inverse. Okay, clear? That's all for this video. You have to practice similar problems from the chapter, and if you have any queries, write a message on the chat box. Okay, so did you like this video? Please like, share this video, and subscribe my channel to get more videos. Thank you for watching this video. Thanks a lot.